Okay, so today we begin the discussion of similar shapes, and we'll start at the highest level, similar polygons. And polygons are similar if they have the same shape, but potentially different sizes. In fact, if two shapes are congruent, they are similar. They just happen to have a scale factor, as we'll learn about, of 1. Polygons are similar if, what do you think is true about their angles? All corresponding angles are what? Good. All corresponding angles are congruent. What about their sides? Like, look at this example. These are a pair of similar triangles. The sides won't be congruent, will they? Any guesses what we might find in the relationship in the sides? Good. Or they're proportional, right? All corresponding sides are proportional. And we've talked about proportionality recently. It's basically when you create a ratio and set it equal to another ratio. And if we take one of those ratios of corresponding sides of a pair of similar shapes, then that ratio is called the scale factor. So take, for example, this scenario. Would you agree that angle A and angle D are the same size? And angle B and angle E are the same size? And angle C and angle F are the same size? So we've got the first part, all corresponding angles are congruent. We need to see if all corresponding sides are proportional. So let's say that I want to create a ratio with 8. Which side would be corresponding to it? How'd you know that? Good, because it's pinched between the 1 and the 2 angles. You can also say that 8 is the what? Smallest, mediumest, or largest side. So which one matches over here? 12, also smallest. And what I'm saying is that this ratio, while I could call it the scale factor by reducing it, that scale factor should be the same for any other pair of sides. So let's take the mediumest side, the 10. That's going to be on top. Why is it on top of the fraction, not below it? Good. It's on the same triangle. In other words, really what I'm producing here is two ratios of the littler triangle over the big triangle. So I'm choosing a littler side, the smallest one, over the bigger version of the smallest side, and then the mediumest side of the smallest one, and matching the mediumest side of the biggest one. Now, is this a proportion? Well, anytime you set a ratio equal to another ratio, it's a proportion. But the real question is it a valid proportion? In other words, are these sides being expanded at the same rate? The way we check that is by cross multiplying. So I'm going to say 8 times 15 will equal the other pair cross multiplied. 12 times 10, 80 and half again is 40 is 120. 12 times 10 is also 120. That shows me that these two pairs of sides are in the same proportion.
If it's also like an easy number like this, couldn't you use like factors like 4 goes into 8 and 12, so it's 2/3, and then 5 goes into 10, 15, so it's 2/3.
So that's what we're going to talk about here is the scale factor. There is a way you could look at it and say, are the scale factors consistent? In other words, 8/12 reduces, as you were saying, 4 times 2 over 4 times 3. So that reduces to 2/3. And yes, you could do that for each one. But is this faster or slower? Really? I've only done it for 2 of them, and that took longer than I think doing this one.
Well, I do.
But you can't do it in your head. You got to show it, right? How do we know that something is true? Okay, so we've now shown that this pair has the same proportional side lengths. Now we need to get the third pair in place. So we'd need to find that these two are in the same proportion as either one of these. So I could say like 14 over 21 equals what? I could say 2/3, couldn't I? Because that's the same ratio we've already reduced. You could also say 8/10. I like 8/12, I guess would make more sense. 8/12. So 8 times 20 is 160, and another 8 is 168 equals, yep, 168. That works. Okay. So one more thing. Take a look at the perimeter of this shape. Perimeter means what?
All the sides, added up.
All the sides added up. So 8 plus 14 is 22, and 10 is 32. And what's the perimeter of this one? 27, 37, 47, 48. What do you notice about that? Okay. So if we took like 32 over 48, you saw that this is 8 times 4 and this is 8 times 6. Does that make sense? If we know that these two shapes are in a scale factor of 2 to 3, then wouldn't the length of adding up all the sides also be in the scale factor of 2 to 3?
Doesn't that mean you also have to find the, scale factor then, as well as the other one?
Yeah, we're going to have different occasions when we're looking for the perimeter, and the scale factor would help us with that a lot. We'll also be just trying to identify the scale factor sometimes. So let's talk about what it looks like when we say, what is the scale factor of ABC to DEF?
Uh,
2/3?
no, it's greater.
Yeah.
Good. I like the way you're thinking about that. Would you agree that the ABC is the smaller one and this DEF is the bigger one? So if we want to go from ABC to DEF, are we multiplying by a number bigger than 1 or less than 1? Greater than. So what you want to think about is it's image over pre-image. Remember, we talked about that with dilations. Image is after it's undertaken the transformation. So in this case, it would be, maybe we choose 12, one side from the image, and then divide that by a corresponding side in the pre-image. And then again, we can reduce this. This is 4 times 3 over 4 times 2. So it reduces to 3 over 2. The scale factor from ABC to DEF is 3 to 2. What about the scale factor from DEF to ABC?
2/3.
2/3, right. What about the ratio of the perimeter from DEF to ABC? Again, we're going to the small one. Good. So it's going to be the same ratio as this. Now, I will warn you that sometimes the notation and the way these are written is confusing. If we're talking about the ratio of the side lengths in this, and I were thinking about triangle DEF, little colon here to say that it's a ratio, this one would end up being 3 to 2, wouldn't it? But if we're talking about a dilation with a scale factor going from this as the pre-image to this as the image, that's where we'd see this as the scale factor. A little confusing sometimes the way that's written. But assuming we've identified that some shapes are similar, we'll talk later about how to prove that they are similar, we could create a valid similarity statement, which looks a lot like our what's. Hold on one second. What do these look like when we have these with different symbols in them? What do you call those? Good. Triangle congruent statement. So these are just similarity statements. Very, very similar. What was your question?
Question about the one, for the, what is the ratio of the perimeter from DEF to ABC? Would it not be 3/2, so it's from the big one to small one?
Going from the big one to the small one.
Oh, because of the decrease one.
Yeah,
You're the dentist. I did this just to you or also
to the office. Yeah, you can go now. Okay, so we're going to write a similarity statement for these two triangles that I made such a mess out of. What do we call this first triangle?
ABC.
Okay, ABC. It is the pre-image if we're looking at going this way. And once I've established the first one, I'm going to put this similarity symbol, which is like the tilde on an enye. And then I'm going to find the second one. And now I have to be careful about how I note this. Which is the corresponding angle to A?
P,
Good. D. Which is the corresponding angle to B? And then F. So that's a similarity statement. And if we're given a similarity statement, we can identify not only the corresponding sides and the corresponding angles, but also which angles are congruent, and we can write a proportion of the sides in terms of how they're related. So let's start with the angles. Here we're given that triangle JKL is similar to triangle PMN. I'm going to notate it in my picture. Angle J is congruent to what angle?
P,
P. So I'll mark those both with one mark, and then I'll say angle J is congruent to angle P. What's another angle pair we could use?
KM,
Good. K, which is the second letter here, and M, which is the second letter here, match up. So I can say angle K is congruent to angle M. And our third angles will also match up. Angle L is congruent to angle N. Any questions on angles and how you can read them from a similarity statement to identify which ones are congruent? Okay. In terms of side lengths, JK corresponds to which side length? Careful. Up here, JK is letters 1 and 2, so which one would match to it?
Yeah.
Good. So JK over PM, that ratio, also called our scale factor, will equal what other ratio? Good. KL to MN, you chose the second and third, which would also equal what other pair? LJ to NP. In other words, all those side pairs are proportional. They're in the same ratio. And again, our similarity symbol is this little mark. Okay, go to page 2, please. These are just like the two we just did. Make sure you pay attention to the similarity statement. And down here, we're going to be looking for the missing values. I would have done a couple of things differently in designing this worksheet myself, but let's take a look at this for a second. If the figures below are similar with a scale factor of 2 to 3, find the value of X. Would you say that the one with the X on it is the image or the pre-image?
image,
In other words, it's an enlargement. Okay. So when I write this scale factor, should I write it as 2 over 3 or 3 over 2?
3 over 2.
Okay. If I write it as 3 over 2, honestly, I could have done it as 2 over 3. It wouldn't be a problem. But the trick is, whichever one I choose, I need to align these two the correct way. Which is bigger, the top or the bottom?
Bottom.
So in this case, which do I expect to be bigger, the X or the 42? So I'm going to put the X with the 3 and the 42 down here. And I could have done it just as easily over here, right? I would have said the way I wrote this was little over big. So what would be my ratio over here? 42 over X. I would have flipped them over. Either way, you'll then use our cross products to solve for X.
Yeah.
If this is a real proportion, which we're saying it is, then we can cross multiply. 2 times X equals 3 times 42.
Equals 60.
Divide by 2, X equals 63. Easy peasy. 5, I got this. 3, starting to get it. 1, this is gonna be hard for me. Okay, good. Any questions? Yeah.
Does it matter where the shapes are? Like the order of like which one's first?
It does, and that's why I said I don't love this particular problem on this worksheet, because they didn't specify which one is 2 and which one is 3. Instead, they're making us look at the picture and assume that this one is smaller than this one. So the 2 we know lines up with the smaller one, the 3 lines up with the bigger one. We can't. That's exactly what I'm saying. Same idea. If they had given us that information and they told us that the scale factor was 2/3, then we'd know exactly what's going on. They're giving us a little bit less information than that. Let's take a look at number 7. This gets a little bit harder. Now they don't even give us the scale factor. They're telling us that PQRS is similar to WXYZ. So do you agree that we have to get X involved somehow? Because we got to solve for X. Okay, so I'm going to put X on top of this fraction. X over what?
32 over 32.
Over 32? How'd you know that?
Because SR and YZ.
Good. You see here that SR is where X is. It's the third and the fourth character. So our corresponding side will be YZ. In this case, that's 32. And by setting up my first ratio, I've already picked. It's my X1, which is to me the bigger shape, over my 32, which to me is the littler shape. Right? I've already set up that my fraction is going to consistently be like that. The bigger number on top and the little number on the bottom. Yeah. Perfect. Well, is that right? You've got the right numbers, but if I put 40 over 75 here, good, exactly, because 40 doesn't line up with the big one. 40 is one of the smaller ones. That's exactly what I was pointing out at that moment. It is. It's a bigger number, but we cross multiply. 40 times X equals 32 times 75. 40X equals 2,400. So X comes out nice. 32 is 8 times 4, and 4 times 75 is 300. And so 300 times 8 is 2,400. Yep. My paycheck is slightly smaller. Okay, so take a look at these problems, please. They should all be similar. When you move on to the back, we're going to have some algebraic expressions. Make sure to pay attention to your similarity statements.
Wait, 40 X equals what?
Say again? 60. 60.
40 X equals what?
Oh, 2400. Okay, this is your homework. Please wrap this up as homework number 66. Please change the number on the front. It's homework 66. Yep. Thank you.